0.07 inches of fertile soil disappear from North American agricultural lands every single year. Why is this specific rate of degradation considered critical? At first glance, the loss appears negligible against the vast scale of the continent. But at this steady pace, the United States risks retaining only 5% of its intact land in just 30 years. This trajectory is capable of pushing a global superpower to the brink of resource exhaustion. Modern science continues to struggle for a technological solution to halt this decay. However, the answer unexpectedly emerged from an idea once considered the most outrageous in conservation history: bringing bison back to the dying lands. One can notice how the return of this giant species triggers a sudden ecological shift. Barren ground transforms into thriving grasslands in a span of merely 10 years. It seems impossible that animals alone could fix the damage, but in reality, they act as the greatest engineers of the prairie. And this is not the limit. To understand the mechanism, we must look back at the tragedy that has unfolded across the plains for more than 400 years. Tens of millions of bison once moved like living black rivers across green fields, acting as the beating heart of a unique ecosystem. This massive sea of grass, stretching from Canada to Texas, was known to scientists as the Great Bison Belt. Before humans set foot on this continent, these animals, which Americans still famously refer to as the buffalo of the United States, powered the entire landscape. But this is just the beginning. Europeans arrived in North America in the 16th century, and the balance began to spiral in a catastrophic direction. Why did the population collapse so violently? The decline happened with terrifying speed across the plains. At first glance, it seems like simple hunting for profit. But in reality, it was a silent strategy to weaken the livelihoods of indigenous communities. The frenzy of hunting for hides and meat was merely a tool to pave the way for European settlement. Consequently, the count plummeted from 60 million to just 325 in less than a century. While a small number were protected in isolated areas, the rest of the prairie was carved apart by farms, plows, and cattle herds. One can notice how the soil became compacted and native grasses withered. The microbial systems beneath the ground were shattered without the herds. It gets more complex further on. One can observe the ultimate price of this destruction in the historical records of the Dust Bowl of the 1930s. Hundreds of millions of tons of topsoil were blown all the way into the Atlantic Ocean. That devastation forced the world to recognize that the prairie cannot survive without the very animal that shaped it for thousands of years. Over $10 million in research funding stood behind an idea so bold it bordered on the absurd. In the early 21st century, when every modern technological solution failed to restore the ecosystem, a small group of ecologists proposed a radical shift. They stopped trying to artificially modify the chemical composition of the soil. Instead, the scientists placed a bet on changing the grazers inhabiting the land, allowing nature to operate exactly as it did before human intervention. But this is just the beginning of the experiment. The team introduced a herd of bison into a territory that was already considered ecologically dead. Why release massive herbivores onto ground that consists only of dry, cracked earth? Every scientific prediction model suggested that the animals would not survive for long without visible grass. But the reality proved completely different, defying the initial calculations of the researchers. Immediately after the release, the herd vanished from the observation screens. Drones circled the perimeter without success, and helicopters scanned the terrain from above. Even the GPS trackers attached to the animals failed to relay their positions. At first glance, it seemed the herd had perished or escaped the experimental zone, but in reality, they were moving with specific intent. The animals were migrating silently toward higher ground, where vegetation was almost non-existent. The disappearance meant the entire project stood on the brink of total collapse. the potential loss of the herd threatened to drag down the most ambitious ecological restoration effort in decades. 250 scientists faced the prospect of losing their jobs if the hypothesis failed. It gets more complex further on. One can notice how the behavior of the species shifts when they finally feel secure. Bison do not possess the puzzle-solving intelligence found in dolphins or crows. However, they rely on a survival instinct refined over tens of thousands of years of evolution. A bison calf learns to swim from its earliest days, with the mother always positioning herself behind it to plunge into the cold water if danger appears. This unique blend of courage, persistence, and herd protection makes them perfect ecological engineers. Without any intent to play a role, the species simply lives, and in doing so, heals the land. 1 ton of living weight impacts the soil with every step, acting as a catalyst for ecological engineering. Their sudden disappearance was, in fact, the first signal that the bison had survived and returned to their natural role as restorers of the land. Unlike cattle, which tend to stand in one place and compact the earth into hardened patches, bison move constantly, never lingering too long at a single point. But this is just the beginning of their work. Why is this perpetual motion so critical for the prairie? To the untrained eye, the difference in grazing patterns seems negligible. However, stationary cattle seal the surface, whereas bison steps loosen the topsoil. This action opens tiny channels that allow rainwater to soak in deep instead of uselessly running off the surface. One can notice piles of dung scattered along their path, providing a natural source of nitrogen, phosphorus, and potassium. These are the specific elements native grasses have lacked for decades. It gets more complex further on. When the animal rolls on the ground, its nearly 1-ton body carves out shallow depressions that function like natural water collectors. At first glance, this looks like simple wallowing, but in reality, these pits retain moisture, letting it seep slowly into the ground to sustain life longer. It is visible how seeds fall into these damp micro-nurseries to germinate. The rolling process also mechanically strips away old, dead vegetation, exposing the bare patches that seeds desperately need to sprout. Remarkably, the source of these seeds is often the bison's own fur, which traps and transports them across the plains. Most importantly, the herd never overgrazes, leaving behind land with enough time to regenerate naturally. 3 years is exactly the time required for small green patches to emerge across the seemingly hopeless terrain. Why did the ecosystem recover so rapidly? The healing process began quietly from the very first footprints they left. But the ecosystem seemed to remember its ancient function, restoring itself through thousands of years of evolution. By the 4th year, native grasses returned in force, covering the soil. One can notice how the landscape shifts from barren earth to living vegetation. But this is just the beginning. By the 10th year, aerial drones recorded a scene that no one believed was possible. A near-dead desert had transformed into a vibrant grassland full of color. Bird species absent for 20 to 30 years began to return to the area. It is visible how pollinating insects reappeared along with foxes, coyotes, and bobcats reestablishing themselves. Streams that once dried up in summer now held water longer due to the soil's improved moisture retention. Findings from the Kansas-Kansa Prairie show that in areas with bison, plant species richness increased by up to 86% over more than 3 decades. At first glance, it seems that any grazing animal would work, but in reality, the ecological role of bison cannot be replaced. Meanwhile, areas grazed only by cattle increased by around 30%, and places without grazers were the least diverse of all. It gets more complex further on. Cattle, despite their similar appearance, cannot create the same positive impact. They stand in one place for too long, compacting the soil and breaking its structure, which causes severe erosion. One can notice the difference in ground density where traditional livestock graze. Regions where bison have been reintroduced are now expanding. The Tallgrass Prairie Preserve in Oklahoma, once a cattle ranch, has become the largest restored tallgrass prairie in the world. Its herd has grown from 300 bison to nearly 2,000 individuals. Thus, the prairie returns to its natural state. 3,200,000 acres is the massive scale of the wildlife corridor planned for the American Prairie Project in Montana. The ambitious goal is to establish a population of around 10,000 bison to roam freely across this vast territory. In regions like Illinois, abandoned industrial zones are being transformed into vibrant prairies solely due to the return of these large herbivores. One can notice how the landscape shifts from gray, lifeless remnants to green pastures as the animals graze. But this is just the beginning. Why is the simple release of bison often insufficient to fully restore the ecosystem? To the casual observer, it might seem that nature simply needs time to heal on its own without intervention. However, many regions require the controlled application of fire, which served as an essential component of prairie ecosystems for thousands of years. Managers in Oklahoma intentionally burn 1/3 of the reserve every single year to strictly mimic natural historical conditions. The flames effectively remove layers of dead vegetation and trigger the strong, rapid regrowth of young grasses. It is visible how the fire clears the ground, creating ideal food sources for the herd. Transition to the next level. At first glance, reintroduction seems like a simple biological addition, but in reality, the synergy of bison and fire revives the land more powerfully than any artificial method. In Mexico, where the species had completely disappeared since the 19th century, a herd reintroduced from just 23 individuals in 2009 has now grown to over 200. This expansion is actively reviving the entire Llanos grassland. One can observe the ecosystem recovering its vitality, where it was once stagnant. Data collected after 10 years of reintroduction reveals a staggering physical transformation of the soil. Moisture levels increase by 25 to 40% immediately after rainfall events. Erosion decreases by nearly half, stabilizing the ground, while plant species richness rises by 70 to 80% depending on the region. And this is not the limit. Remarkably, areas that once lost all vegetation have turned into thriving biodiversity hotspots without human engineering. No technology, irrigation systems, or artificial fertilizers were required. Everything was achieved simply through the presence of bison and nature. Millions of bison. That is the scale required to return the Great Plains to their historic form after thousands of years of change. The success of recent restoration projects raises a fundamental question about the future of the continent. Could severe soil erosion, widespread land degradation, and even the accelerating effects of climate change be reduced simply by allowing nature to resume its work? Bison have effectively accomplished what humans have failed to achieve despite hundreds of years of intensive soil management. One can notice how they transform a dead, barren landscape into a thriving, living ecosystem. But this is just the beginning. Why is this biological approach more effective than modern engineering? It seems that advanced technology should offer superior solutions for land recovery. However, ecological restoration does not always come from expensive machinery, but from understanding how natural systems function and restoring the missing pieces. One can notice how their heavy hooves churn the earth, aerating the soil naturally. Their dung provides essential nutrients, while their rolling bodies create depressions that collect water. When these animals disappeared, the prairie ecosystem collapsed almost immediately. When they returned, the land began to live again. The revival they produced after only 10 years astonished scientists observing the change. But the situation is more complex than it appears. A significant economic paradox threatens this natural recovery. 95% of bison today exist only as a commercial product within the meat industry. Just 5% remain as true ecological engineers, the only individuals still capable of reviving an entire prairie. The bison meat market is now worth over $350 million annually in the United States. Demand rises steadily by 10 to 15%, driven by the meat's reputation as a high-protein, low-cholesterol superfood. At first glance, the species seems to be thriving economically, but in reality, this value pushes most animals into industrial farming. This unintentionally shrinks the chances for the wild species to recover naturally. Their ancient migration routes once kept an entire continent functioning efficiently. The story of the bison serves as a reminder that prosperity often depends on the most overlooked links in nature's chain. Sometimes, the most powerful solutions to modern crises are the ones written into the land long before human arrival. The potential for recovery relies on whether society has the courage to let millions of these animals save the dying landscape.